Okay, so last time we were writing our little converter program dealy flippy thingy that took our decimal 2989 for example and converted it to base 16 was our last thing. If we convert it to base 8, this works just fine. Goes through, does its stuff. So 5655 in base 8. But we had an issue at the end of class where if we want to convert it to base 16, this should be the number BAD, but instead it's giving us 11, 10, 13, which should translate into BAD. So what we need to do is we need to add on to our program in our ghetto way right now to make this conversion happen. How would you go about doing that? I think we had to do it for homework, right? Anybody have any interesting ways of solving it, or we just do the brute force if statement way of solving it? A bunch of if statements. So what did we do? We go into answer. Maybe we create a...
I created an integer. I didn't know I could do that.
Create an integer for current remainder.
Yeah. And then set that equal to the...
Yep, so what we'll do here is we'll change not our answer.
You can remove concatenation from this step and do it afterwards.
We're going to do a couple of things here.
Then I put that inside the...
I actually want to see if this will work. I'm going to add another... I want to create an attribute called toConcat. This will actually tell us whether this stuff happens linearly. So what are we going to do? We're going to take our games decimal and mod it by game.toBase. So we're going to set our answers, current remainder, equal to our games decimal, mod, our games to base. That should give us the remainder. Okay? But before we add that onto our answer, we need to set up we need to do the conversion, right? So now we're going to add a rule. This rule is going to say answers current remainder is less than 10. Oh, sorry. Less than 10. If it's less than 10, we're just going to go ahead and concatenate it on. Right? So what we're going to do is we're going to set toConcatenate. Change answers toConcatenate to be equal to I think we should be able to put an int into a...
Yeah, it worked.
Now, just real quick to talk about this. What we're doing here is we're setting a variable called toConcat, which is a text, a string, if you will. We're setting it equal to an integer. Most programming languages would not let us do that. So for instance, if we were in Java and we had a string called toConcat, and we had an int called current remainder, and this guy was 5, we couldn't say toConcat is equal to current remainder, like we're currently trying to do. Because this guy on the left-hand side is a string, text. This guy on the right-hand side is an integer. This guy's built for holding text. So what we do in a language like Java is we take the empty string and concatenate to it our remainder. So this would allow us to effectively put that integer into the string, but we'd have to turn it into a string first. That make sense? So game salad syntax for concatenation is ... That. Java's is just the plus sign, and it recognizes if one of the sides is a string, treat this as the concatenation operator, not as the addition operator. Okay, so a language like Java would force us to cast it to the right type first. He's saying that game salad will do that cast for us. It'll let us shove an integer into a text. Okay, so that's what we're going to do if our current remainder is less than 10. Otherwise, if the current remainder is not less than 10, that means it's 11, 12, 13, 14, 15. Correct? Because you were only supposed to make this work for up to 16. That's to keep you somewhat sane for the number of if statements we have to write. Okay, so we're going to say, we're going to add a rule. If current remainder is equal to 10, change attribute to concat to an A. And I'm going to copy that rule. Is equal to an 11.
How'd you do that? Saved me so much time.
Control C.
Hold on, it hasn't necessarily worked yet. In the past, Game Salad has had some issues with copying things and then repasting them. But let's just assume for right now that I'm awesome. On a Mac, it's Command C to copy. On a PC, it should be Control C. And then Control V pastes. Command V pastes. Does that work?
It worked that time.
All right, so that's for the B.
That's kind of touchy on Windows.
But you do need to kind of create a skill set of knowing how it's going to paste. So I've clicked into the space I want it to paste. Nothing's highlighted. You need to make sure you, okay, right there. So now it'll paste it. 12 is a C.
Oh, you cannot control paste into the little text box.
13 is a D.
Let's just go that
Huh?
far. Let's just go that
Just,
far.
well, we're almost done. $14 is an E. $15 is an F. Okay, I'm going to go ahead and get rid of.
You still need
Okay, so after all that stuff has happened,
It's 16 though. Are you gonna have to
No.
You're gonna have to put single
Can't have a
quotes
remainder of 16. What's
You're
up?
gonna have to put single quotes around the letters.
Well, I guess we're going to find out. I don't think so. I don't think you have to in Game Salad.
Because I had 2 for mine.
Oh, then maybe you do have to engage. You would have to in Java. So we're going to, actually we're not doing that there. Yes, we are. We're changing our answer to whatever it currently is.
And what you get first.
Oh yeah, we gotta go backwards. Our answer is to concatenated with the answer. Okay, so this whole if structure goes through and it determines what we're actually going to concatenate by either just saying we're going to concatenate on the number if it's less than 10, or here's the letter equivalent. Okay? And then we'll update our decimal at the end. All right, so you're saying this is not going to do the concatenation?
I don't think so. Maybe it's because I concatenated in the same variable.
Or you're on a PC? Could be. So there's our conversion. Okay, so at this point it has been confirmed that I'm awesome.
Yeah, sure, why not?
A lot of times the cut and pasting does not.
No.
It's not that it doesn't work in Game Salad. I've had some experiences though, especially I think if I remember correctly, with change attributes. That you'll copy something and it doesn't actually update. That could be an older beta version of this. Well, we're still on beta of Game Salad, so just be aware that sometimes copying and pasting, it looks like it's there, but the rule doesn't necessarily fire the way you think it's going to fire. Let's make sure this works on other things. So let's go back to our scene. Go to our games attribute. And let's convert, let's just do this to base 8. That way we should always get remainders less than, make sure those concatenations work. Okay? Make sense? All right. So now what we want to look at today, and we're actually going to watch a shortish video first of them showing us how to do it. Tables are very new in Game Salad. Last time you asked if we had arrays, correct? You asked if we had arrays. Go ahead.
Like in Java, couldn't we do the same thing by just like adding a certain number to turn it into ASCII values and then convert it to?
Well, Java, there's actually some really cool tricks we can do for this. We'll do that. We'll do that next semester. But yeah, Java, you can make this really short. Actually, Java, you can make this one line because it's already built into Java. There's a tool built into Java for it. But when we do it next semester, we'll do it the, oh my God, I hate my life way. And then I'll show you the punchline. And I'll show you even a better punchline. I like the suffering.
Thanks.
Yeah. Well, this assignment wasn't that bad. It was just kind of tedious, right?
Yeah.
Was it tedious, or it was yes, it was that bad?
Combination.
Which is which was that?
Combination.
Okay, so just quickly, that's 250. This is 200, right?
Yeah.
So just to give you a quick little overview. All right, so let's talk about arrays at a very high level right now. We talk about them in a lot more detail next semester. But an array is a collection of like elements under a single variable name. So for example, in our thing here, our problem we're trying to solve here, we might have a collection of chars where we might have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So we might have all of those in an array. Okay? And if the remainder is 5, bucket 5 of that array holds a 5. If the remainder is 10, bucket 10 of that array holds an A. Does that make sense? So under a single attribute, under a single variable name, we can have a collection of data. Now, arrays historically have not existed in GameSalad. GameSalad just this year has introduced a new tool. I'm not sure how buggy it is because I've never actually used it. Okay? It's very new. And it's called tables. Now, just to kind of give you, this is my understanding of tables, and we'll amend this after we watch the video. A table is somewhere between an array. Well, here, let's create another slide. So it allows us to solve array type problems. It also allows us to solve problems that involve file I/O, bringing information into the game, for example, from outside of the game. So if you want to have a bunch of tables, if you will, containing information about monsters and that kind of stuff, you can do that. It also solves the database problem. Okay? So each of these is kind of a evolution of each other. So arrays were a local way of storing multiple pieces of info under a single variable name. A file was a local way of storing multiple pieces of info under a single file name, which could be read in when needed. Think of that as being slow. Think of this as being fast. The difference is it's tedious to fill an array up with data. It's not necessarily tedious to fill up a file with data, especially adding, removing stuff from it. So what's a database? A database was the evolution of these two. This allowed us to have a local way of storing multiple pieces of info under one or more table names and allow us to query those tables. Well, let's just leave it at that. Query those tables. Most databases today, most modern databases, we think of being able to query them with a language called SQL, structured query language. So when we get into our future classes, we'll be using different, you might be using a database management system called MySQL. Another competitor with it is Microsoft SQL Server. Another competitor would be Oracle. Okay, these are all relational database management systems that all support SQL. The more modern, so the next level of evolution beyond this is something called a cloud data store. Okay, now here's the deal as we kind of go through this. We talked about the Y2K bug in here, right? Okay, good. Just wanted to put your mind into that mode a little bit. Arrays are great. Well, actually, probably file I/O came before arrays, reading stuff from a file. The problem with that, it was very slow. So the reality is if you were reading from a file while your game was running, we'll just keep using game as our example since we're using GameSalad. While your game is running, if you were constantly reading from files, your game would slow down a lot. I think did I show you the for loop in here that went really slow in Java? Yeah. Okay, so the second you start doing input-output, things slow way down. Now, when we showed you that for loop that went through and it was just printing some number to the screen over and over again, that's just printing to the screen. That is way faster I/O than reading from a file. Files are slow. A file can only give you information as fast as the medium it is stored on can give it to you. So maybe our fastest file would be on like a solid state drive today, an SSD drive. But those are still way slower than memory or anything like that, right? After that, you have a mechanical hard drive. Serial ATA, maximum speed of 6 gigabit per second. Okay, whatever, it's still a spinning disk, and it's going to take time to go to the location where that file is, then stream it into memory, then we can start reading from it more quickly. Go back old school, we go to our 3.5-inch floppy disk. Slow. Okay.
Small.
Well, relatively speaking.
Right.
You know, a 3.5-inch floppy disk was 1.44 megabytes, you know, which we consider to be not even big enough to hold an MP3 today. But back then, you could have thousands of files on it. See, you know what I'm saying? Everything's relative. You know, our internet speeds keep getting faster and faster and faster, but then what else happens? Our files get bigger and bigger and bigger, so everything kind of scales. You know, the amount of time it takes us to download something that we might want today isn't necessarily drastically shorter than it was to download something that we wanted 6 years ago. The size of what we wanted changed. Internet speed kind of kept up. Does that make sense? So, database was really a fix for this. How do we have programs that access information that allow us to have powerful ways of getting the exact information we want, rather than having to build all these custom functions into our programs for saying, well, if I have this array filled up with crap and I want to get only these pieces of information, I need to write this function. If I have a file filled up with this crap and I only want to get these pieces of information, I need to write this function. Databases allow us to throw all our crap into one place, organize it there, and then they give us a consistent language for saying, give me just this. Now give me just this. We don't have to write all these individual functions. Make sense? So databases would be our power tool. Let me just throw a little word in front of this. Relational database. One of the goals of a relational database, so this kind of goes back to a Dr. Locklear concept of grand ideas in computer science. All these things are kind of connected together. One of the goals of a relational database that you'll learn about when you take Professor Wall's database class is they have a goal of minimizing the duplication of data. Okay? That's a very Y2K friendly thought. Because back then, our hard drives weren't that big. Our memory wasn't that big. The less stuff, if we could store the same data in a smaller footprint, that's a good thing. Right? We don't care about that today. I mean, how many of you have a hard drive bigger than 1 terabyte? You got one person? Are you serious? Okay. Greater than or equal to 1 terabyte. All right. How many of you have 2 terabytes or bigger? 3 terabytes or bigger? Do they have I think, is it 3.5 the biggest they have now? Or is 3?
It's 4.
4 terabytes? Is yours a 3 or is it a 4?
Sure, it's either a 3 or 4.
Yeah, it's either, if it's big, it's probably either one of those, probably. But yeah, if 4 you're saying is the biggest right now? Yeah, next week it'll be a 5 or something. But you know, you get the point. You know, a terabyte of data is 1,024 gigabytes. It was amazing when you could buy a 2 gigabyte hard drive. People are like, oh, we're never going to fill that. Yeah, he probably has his 4 terabyte drive 3/4 filled with music. I'm sure completely legally purchased. We are ethical Concordia students. Right? So, but the point is that storage is not a problem anymore, right? You know, one of my machines, you know, it could be somewhat of a problem. A good example would be this. Time is kind of rebooting on itself. So this is a really nice laptop. It's a 15-inch MacBook Pro Retina display, 16 gigs of RAM, quad core something or other, and it has, I want to say 512 gigabytes of solid state hard drive. very fast hard drive, very good hard drive, but we could conceivably fill a half a terabyte today, correct?
Mhm.
I do have to be somewhat aware as I just randomly put crap on here, especially with Dropbox. So everybody in here uses Dropbox now, right? I've yelled at you. Have we done that already? Okay, so here's my Dropbox. I have, does it tell me my total storage? I have like a 3 terabyte Dropbox from my development team. And so I need to pick and choose what I'm going to allow it to sync to this computer so it doesn't fill my hard drive up. Does that make sense? Okay, so I do need to be somewhat aware, but the benefit I'm getting from that is a very, very fast machine. One of the main things that slows your computer down actually is the hard drive. A lot of people say, well, what's the first thing you upgrade on a computer? Well, I can tell you one of the last things you upgrade in a computer is the processor. One of the first things you upgrade in a computer is probably going to either be hard drive or memory. If RAM is really low on your computer, probably bump the RAM first. But if you have an adequate amount of RAM, you'll always gain much more noticeable performance by adding a faster hard drive. You know, a 10,000 RPM Western Digital Raptor drive or something like that. You'll have a noticeable improvement. RPMs are out the window with a solid state drive, so get a fast solid state drive and you don't have to worry about your computer melting. How many of you have ever installed a mechanical hard drive that was a really fast RPM? Had like a heat sink all around it and stuff like that. Like sometimes even difficult to fit into the slot because it has so much heat dissipation technology built into it. Those things would. I tell the story sometimes. I don't know if I told it in here when I was undergrad. A buddy. This was back in the days when overclocking processors was like what cool kids did, the cool geeks did. Now there's like software to allow you to overclock your processors. Back then you had to go in and like solder things. You know, like jump pins on your motherboard to overclock your processor. I mean, it was a involved thing, kind of like some of the console gaming mods that some of you, I'm sure, never have done today. You can buy the kit. What does it come with? A little template thing. Just lay this over it and solder in these holes. Congratulations, your Wii will now play whatever game you want. Informational purposes only. I'm sure none of you have ever done that. But in any case, what was I getting at with that? Oh, I was the story. So this guy down the hall, it was an Intel Celeron processor. And these processors they're famous for being some of the most overclockable processors in history. Okay, so he had like a 233 megahertz Intel Celeron processor overcooked to like 2.5 gigahertz. Okay, we have like 2.5 gigahertz processors today. Now they're much better architecture, much faster architecture, so you can't just compare gigahertz to gigahertz, but he was really overclocking this thing. Okay, so in his room, he had this case open. He had a bunch of fans just blowing into this case. 4 in the morning one day, you hear this screaming in the hall. He comes down, he's banging on my door. I come out. You look down the hall, so I'm like the first room right out the elevator. He's all the way out the end. There are flames billowing out of his room. Okay? It's literally like the gates of hell are at his room. Okay, I think that's a Christian worldview. Gates of point. Gates of hell were, his whole room was afire. We got that room out with one fire extinguisher. The room was demolished. The whole place was melted. His bed wasn't a bed anymore. The frame was all like goo. Yeah, that was awesome. No, actually, that was back in the day. I think that the floor had to share in the damage. Man, do they do that still? Okay, so yeah, like if somebody on your floor like breaks a light fixture or something like that, the whole floor is kind of assessed, $2.50 to replace the. Yeah, this room costs a little more than $2.50.
If the person gets caught,
Just
just go straight to them.
Okay, I got it. Yeah, I'm pretty sure that the whole floor is maybe assessed I want to say maybe like $275 or something like that. But we all knew him really well, and it was worth it. Totally worth it. I mean, this was the type thing where this is like a 25-story dorm room. This is a big school. This was a type of starting point where you think the building might come down. That's how much fire there was in such a small location. It was awesome. Okay. So anyways, back in those days, we really needed to worry about minimizing our data footprint. If we can store the same amount of data in a much smaller footprint, we cared. That's why relational databases existed. We still use them a lot today, but they're starting to get phased out because we now have a newer technology that allows us to still query the information, but also retrieve the information very, very quickly. This is kind of where this whole idea of cloud computing comes in. So we have something called a cloud data store. Common ones are Google App Engine, Amazon, S3, that's their actual storage unit. Amazon has a kind of a suite of cloud utilities, but the S3 is their storage, secure blah blah storage. There's a center S in there, but fast, super fast storage, blah blah blah. A tool I use in a lot of my classes now, and you can go check it out if you're kind of ahead of the curve and you're doing some of these things already, is something called parse.com. It's free, allows you to prototype things with data really quickly. So that's actually a cool tool, and you'll be, if you keep taking my classes, you'll use that stuff. Especially when we do like iPhone programming, we connect it to a parse data store. But in any case, the general thing with the data stores is this. Take Google, for example. They have multiple warehouses of servers with tons and tons and tons of fast storage in them, right? Your information is duplicated across hundreds and hundreds of hard drives. So when you query it, it's going to send it to the machine that's less busy right now to give you that data. So it tries to duplicate your data, pays no attention whatsoever to running out of hard drive space. Okay? All it cares about is performance. The data's there, it's there a lot. Okay, you need it right now. Well, these 400 machines are busy, go to this one. Gives you the data more quickly. That's an oversimplification of how data stores work, but that's the gist. Okay? So this has kind of been our evolution of storing stuff. They all kind of solve the same problem. Letting us have stuff we can then access later. So, Game Salad has introduced this concept of tables, which is their rudimentary way of solving some of these problems. Okay? So we're going to kind of end class today by watching like a 12-minute introductory video to tables, and then we'll mess with it next class. One thing I'll tell you, that I don't want to forget to announce, we will not meet on Friday. I was thinking about giving you guys your midterm exam on Friday, but I decided not to.
Well, thank you.
I think we will have that, though, next week. It'll probably either be Wednesday or Friday next week. I will confirm for you, but and I'll tell you kind of what's going to be on it. But probably on Monday we'll talk about it.
All right.
But on Friday, I'm leaving campus early. We're taking a group of sophomores, 3 sophomores and 2 seniors, to a hackathon in Iowa. So I'm driving, and it's like a 7-hour drive. So we're leaving a little bit earlier since we have to be there early the next morning. Okay, so no class on Friday, but let's go ahead and let's watch this video, and we'll come back on Monday and start messing with tables.
I'll send you to the computer science party on Thursday.
Oh,
Oh, yeah.
yeah, don't forget about that.
I'm getting out.
Computer science get together tomorrow, 11:30,
Yes.
right down the hall here. Fun, food and prizes. A lot of times they've given away iPod Touches, printers, monitors.
Professor Wall showed us the prize list yesterday. And
Yeah, it's supposed to.
Is there anything good?
Oh yeah.
Got an
Is-
Xbox
is-
One game.
Okay, so I mean, like
It's
legitimate prizes.
It's a
They're not-
solid state.
yeah, he's not handing out like popcorn and stuff.
It's a solid state.
Yeah, so there's like good prizes. Make sure you're there early.
2 printers.
Flash drive.
So hey, here's a shut up. Here's a quick hint: get there early because there's like a game where you have to like run around and find
Introduce.
somebody who has the same birth month as you and that kind of crap. Yeah, it's a meet and greet thing. But there's 2 prizes for that. Those are the first 2 people that go. So you get, if you win either one of those, you'll get the first 2 picks of the best prizes. Okay, so show up early, do that, and it's free food. So that's tomorrow, 11:30, right down the hall here. Now, we're gonna watch this. This is 8.1 surround sound. All right, so this should give us an introduction to tables.
Here from gshelper.com, and I'm here to show you a little bit on tables. This is an introductory video, just basically goes through a few things that tables can do. Now, tables can do a lot more than what we have available in Game Salad, but this is a great start, and there's a ton of things you can do with the features we have available in tables. Simply open your project, and you're going to notice a new tab here for tables. And you'll notice we don't have any tables. So to add a table, just hit the plus sign, and you can add as many tables as you want, and they all get named. But you can double click and rename them. One thing I want to show you right away is I'm going to name this random number. Let me delete some of these here. Well, I should have opened so many, but just wanted to show you how easy it was. Okay, so I'm going to go into my scene here, and I'm going to go into scene 1, and we'll make an actor here. Now, I'm going to do a change attribute here, and you'll notice now when you go game, the table is right there, random number. Unfortunately, it doesn't say that it's a table here. I would have loved for them to put a folder down here for tables or whatever. So there's really no way to tell the difference between a table and an attribute. So I'll show you here. We'll go in here and we're going to create an attribute, Boolean, just call it FFF. And now I'll go home and I'll create another table. And I'm going to call this player 1. And we'll go back to the scene and we'll go home. And in here again, I'm going to go in here again. And now you'll see, I got my first table, my attribute, and then my other table. And you can't really tell what's an attribute and what's a table. So I really, really, really recommend when you're making your tables, have an indicator. So, maybe TB, random number, and then TB player 1. So now I go back in here, and when I'm working with my tables, game, and now, I know that's a table, and I know that's a table, and that's an attribute. So I really, really stress the fact that you should probably name your tables something that you can distinguish between attributes and tables. That's really important. So let's go into our tables here, and I'm just going to show you the layout on them. As you can see, if you ever used Excel, you'll notice it's pretty much the same. You have one column, and this is a column, and a row is on this side. So that's a row, that's a column. And I can create as many rows as I want, and I can create as many columns as I like. For each row, I can choose if it's a text, integer, real, boolean, or angle. And I'm going to choose text, I'll choose integer, real, angle, doesn't really matter. And for integer, you'll notice I can type 1, 2 dot, and then a bunch of stuff. And when I leave that, it just puts it back to 1, 2, because an integer is a whole number. If you want a decimal, you need to use a real attribute, so 1, 2 dot, some stuff there, and boom, now I got that. Angle, so angle is 0 to 360, so if I do 390, it won't let me. Gotta go to a 360. And text could be anything. And now a lot of you are probably wondering, why would I want this? And I'm going to have a lot of videos to show you different things that you can do with tables. But right now, I'm just going to show you just a brief breakdown of some of how to use them basically. So for more detailed stuff, look for some more videos. As you can see, I have too many columns here. You can simply, press your arrow down and get rid of those columns. Unfortunately with this, I really hope they fix this in the future, but say I don't want column 1 anymore, I can't delete that column, which sucks. One thing you can do though is you can bring it over to another side and then column out of it. But it would be nice just to delete it and have it gone. So again, I'll show you that. You can just drag columns wherever you want them, mix them around, just like that. Back over. You can't do that with rows, just with columns. That's pretty much it for that. You can import a CSV file. So if you are working in a spreadsheet program, the Google Documents or Excel or something like that, and you have your table already made, you can import the CSV file. Also, if you have a table that you built in Game Salad, you can export the CSV file, which is really cool.
CSV is comma separated
Go into,
values.
well, let me just add some stuff here. Delete these. We'll turn this to a text, and I'm just going to quickly run down here. Wrote some words in there. So now I have a table full of words. And I'm going to go home. I'm going to go into my scene here. And I want to tell it to display one of those words. So I'm going to tell it to display text. We'll get rid of that. Go into my display text. And I'm going to tell it to display this table here. And go OK. And you're going to notice here, let me go back. You notice nothing happens. Okay, just blank. And the reason for that is because you have to tell it what to display. So what I'll do is get rid of that. And we're going to go into our expression editor. And you're going to notice we have 3 new options. We have table cell value, table column count, and table row count. For the first one, table cell value, that's what we want. We want to get a value from one of the cells in the table. So now you'll see there's 3 options: table, comma, row, comma, column. So for table, you just delete that, and you add game, and then the table you want to use. For the row, let's just go for a 1 for now. And for column, I know it's in column 1. And that will give us the first word in our table. So I'll hit OK. We'll choose a color, and I'll hit preview. And now you'll see there's the word from the first box. And I'll hit back, and we can go row 2 this time. I'll hit preview, and there's our second one. And 3. And so on. Now what if you just want a random word from one of those cells? That's simple enough. We will go random, and I'll just move my arrow over to get the rest of it. And for minimum, we're going to do 1 because 1 is the start. Then we'll do comma, and we know that there's 5 rows, so I could just do 5, no problem. Hit preview, and green, blue, and it's just picking random ones every time I refresh. But what if you go and add stuff to the columns later?
Now, something that's interesting here is if we went into Game Salad, we go to our tables. Go back here. Come on. We add a table. Let's call this guy map underscore TB table. I'm going to go in here to column 1. We're going to make this guy a bunch of text. We're going to say 0.
Gotta add it up top.
You gotta add rows, columns.
Oh, that's stupid. 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. Okay, so there's that. We create our table. I'm going to go back into our game.
We have to subtract 1 from.
Yeah, we will. So I'll go into answer. So I'm going to get rid of basically all that. All those rules we created. So we'll get our current remainder, and we're going to set our answer equal to not self.toConcat, but instead table cell value. What table? Our games map table. Row.
1. Or,
That's wrong one.
Yeah, 1. Oh, that's
no, it's
Row.
column 1.
Current remainder plus 1.
Minus.
Column 1.
Yeah.
So if the remainder is 0, it'll give us the 0 at row 1. Similarly, if we come in here and we change it to base 16, now it gets us our BAD. All right, so tables, this is kind of an array type of functionality. If any of you have dealt with arrays, they allow us to solve that problem in a lot less space.
Yeah.
That makes sense? Okay. The only reason we had to add 1 is because their tables start at row 1, not row 0. So if I want to get the 0, I need to go to index 1, not index 0. All right. I will see most of you hopefully tomorrow at the computer science get together. And the rest of you I'll see on Monday in class. No class on Friday.
Enjoy your trip.
I'll try.